Okay, in this video we're going to discuss a topic called piecewise functions. Piecewise functions. So a piecewise function is going to be a composition. It's going to be a composition of two or more functions, each with a restricted domain. Each with a restricted domain. So often you will see them written like this. So you're going to have f of x equal to, we could say this is going to be a big bracket. There could be 1, 2, 3 functions. There could be a function, let's make this first one linear. We'll say 3x plus 1, and then there will be a comma here, and then to the right of this function will give the value of the domain in which this applies. So we'll say here that this will be 3x plus 1 when x is less than positive 1. And then we might have the function, let's say x squared. Let's say the function x squared when x is greater than or equal to 1. So we have two different functions here. 3x plus 1, this guy is a linear function, and this guy down here, function number 2, is parabolic. So in this circumstance, this composition, this function f of x is composed of two different functions, each with restricted domains. So I always call these values here, I always call these values critical points, because they are going to denote where our domain exists, or where the function exists in what part of the domain. So let's go ahead and see what I mean by that. So let's go ahead and examine what I mean by that. So what I always like to do is that I always like to graph each function independently. So 3x plus 1 I'm going to graph over here, and then I'm going to graph x squared over here. When we want to graph, I always recommend using a t-chart. I always like using a t-chart. So here, this will be my x, this will be my y, and let's say this will be equal to y. This is going to be y equals 3x plus 1. So we have y equals to 3x plus 1. Then when we have a value of x being 0, we're going to get y is equal to 1. We just plug in 0, so we'd have y equals 3 times 0 plus 1, so y equals to 1. Let's set x be equal to 1, and I'm going to highlight this. I'm going to highlight this because this is in fact a critical point. So when I plug in 1, we're going to have y equals to 3 times 1 plus 1, which gives us 3 plus 1, which is 4. So we're going to have a value of 4. And let's go ahead and make this next value negative 1, and we will have y equals 3 times negative 1 plus 1, which gives us negative 3 plus 1, which is a value of negative 2. And we can graph this on our Cartesian plane, so we'll have 0, 1. So we'll have 0, 1 right here. Whoops. Right here. We're going to have 1, 4, 1, 2, 3, 4. I think that's 1, whoops. 1, 2, 3, 4 looks like that point right. Okay, if I could draw that here. There we go. And then we're going to have negative 1, negative 2. So we're going to be down approximately right here. So now I want to connect this. I draw this correctly. 1, yeah, so 1, 1, 2, 3. Yeah, looks pretty good here. 1, 0. Oh, okay. I graphed the first problem incorrectly. Let me stand corrected. My first point, 0, 1, is in fact, I knew something looked a little off, but it's in fact right there. Yeah, okay, I was off by a value of 1, so, oh my goodness. There we go. And then this point is off slightly too, so this will be a value of 1, 4, so that looks a little bit better. And then we have negative 1, negative 2. Good. So I think that makes this one, that looks like 1, 3. I just can't graph this today. Sorry. So 1, 2, 3. There we go. So now this looks a little bit more linear. So now when I connect these points, I have a linear function. I have a linear function. So I graphed my points. So this is linear as it can be with my ability to graph this free-handed. So now I'm going to come over here and I'm going to graph my parabola. x squared. So I'm going to have an x and then a y, and I'm going to set this equal to a value of y so I can graph it. I like plugging in 0. 0 I plug in, I'm going to get 0, so it crosses to the origin. At 1 I have a value of 1 because y equals to 1 squared, which is a value of 1. Negative 1, we're also going to have a value of 1. Plugging in y equals to, let's do 2. I'm just going to confirm with 2 squared. That'll give me 4. And then here I'm going to plug in negative 2. I'm going to plug in negative 2. Solve y is equal to negative 2 squared, which is also a value of 4 as well. So we have here several points. I'm going to graph 0, 0. Then I'm going to graph 0, positive 1, and negative 1. And then at negative 2, I'll have 1, 2, 3, 4, which will be up here. And then 1, 2, 3, 4, which will be approximately right here. Now when I connect these points to the best of my abilities, I don't like that. So when I connect these points like this looks a little better. I'm going to have a parabola that opens up. So now I'm going to highlight my critical point over here. So notice here, this is my critical point because that corresponds to this value of the restricted domain. When I examine this function, 3x plus 1, only exists when x is less than 1. So we found our critical point. We found our critical point to be 1, 4, which is right here. And it only exists when it's less than 1. So less than 1 means to the left. So it only is going to exist right down here. So it's going to exist where it's red. And then when we examine this second guy, x squared, this only exists when x is greater than or equal to 1. X is greater than or equal to 1. So it's going to exist where I've drawn in blue. But this gets even a little bit more. Well, that's not a very good drawing. I was trying to trace it. Okay, there we go. But this gets even more in depth because when we are looking at our first function, 3x plus 1, it only exists when x is less than 1. Less than 1 and greater than or equal to or less than or equal to are distinctly different. So whenever we see a less than sign, a less than or greater than sign implies that we're going to use an open circle graphically. If you have a less than or equal to or greater than or equal to, that implies that you're going to have a closed circle, So over here, I'm actually going to have to correct this, and I'm going to have to denote this with an open circle at 1, 4, and I'm going to erase everything to the right. I'm going to erase everything to the right because this only exists when x is less than 1. Over here, I am happy because I know here at my critical point here, which is 1, 1, we're going to have a closed circle. But I'm going to go ahead and I'm going to erase everything to the left. So I'm going to erase everything to the left because this only exists when x is greater than or equal to 1. So now what you're going to do is you're going to take these two graphs and you're going to put them together on one individual graph. So let's see if I can, I'm just going to copy this graph and then I'm going to paste down here. So my first value, I'm going to have a critical point at 1, 4. So I'm going to go 1, 1, 2, 3, 4. And this is going to be an open circle. And I know it's also going to cross here at 0, 1. And then also at 1, 1, 2, it's going to cross down here. And we're going to have a line that looks something like this. And then over here, we're going to start at 1, 1. So we're going to start at 1, 1. At 1, 1. And it's going to intersect at the point 2, 4. So 1, 1, 2, 3, 4, 1, 2, 3, 4, which is going to be right here. So it's going to curve something up like that. So this is a basic idea of what this function is going to look like. Again, nothing perfect. In our next video, I'm going to show you how to graph this using a graphing calculator.